Welcome to today's deep dive. Training an AI model often looks a lot like, training a dog with a simple clicker.
Right, the dog performs a trick, and you either click to give a reward or you do nothing.
Yeah, in traditional reinforcement learning, we give a model a +1 or a -1. It tells the model if it succeeded or failed. But, imagine trying to teach a dog to write a Shakespearean sonnet with just a clicker.
It is incredibly limiting. Relying purely on that numeric score creates a severe limitation for the system.
The model just ends up stuck in this highly inefficient loop of blind trial and error.
Yes, because it knows it did something wrong, but it has to randomly guess its way toward the right behavior. That is the bottleneck researchers are fixing today with a framework called GOLF.
Which stands for Group Level Language Feedback, right?
Yes. It replaces that basic numeric score with rich, actionable language guidance to navigate the learning process.
So, if we are abandoning the simple +1 or -1, the framework has to somehow generate actual sentences to critique the model. Where is it getting those critiques?
Well, GOLF aggregates two distinct sources of feedback. First, it uses external critiques, which are explicit notes pinpointing specific errors in the model's output and suggesting targeted fixes.
Okay, external critiques make sense. And the second source?
The second source utilizes intra-group attempts. These are alternative, failed responses generated by the model during the same rollout.
Oh, like the model's current batch of attempts at answering the prompt.
Yes.
That second source sounds a bit like a struggling study group. Imagine several students all get a complex math problem wrong. Rather than just giving them a failing grade, you look at their scratch pads.
By analyzing the different ways those students failed and piecing together their partial ideas, they can synthesize the correct answer together.
That is fascinating. A single critique fixes one error, but aggregating the diverse failure patterns from the whole group exposes the model to much richer context.
And the counterintuitive insight here is that a model extracts a deeper understanding of the problem space by examining its own flawed logic. It learns much more than it would by just being spoon-fed a pristine, correct answer.
Think about the last time you used a chatbot, and it just kept repeating the same unhelpful mistake. The model is trapped.
Researchers actually call that trap a sparse-reward region. The model is completely stuck generating all zero-reward answers, which halts learning entirely because there is no positive signal to follow.
So if synthesizing the right answer from that group of mistakes is the first step, how does the framework actually pull the AI out of that trap?
When GLF detects this region, it adaptively injects those synthesized high-quality refinements as off-policy scaffolds.
Wait, really? If the framework synthesizes a refined answer and just injects it into the training data, doesn't that teach the AI to blindly copy the provided solution?
The mechanism prevents blind copying. When the model reads the scaffold, it is not memorizing the final answer. It is being forced to generate the intermediate steps that lead to that answer.
Oh, wow. So it fundamentally rewires its problem-solving pathway.
That is the core innovation. This process restores the learning gradients, essentially unblocking the mathematical path the model uses to update its internal weights.
I see.
The model is jointly trained to generate answers and self-refine within one unified loop. It does not just imitate.
The scaffold gives it a stepping stone to find the rewarding trajectory on its own. If it is actually using these scaffolds to learn how to learn, that must drastically cut down the time it takes to train.
The data supports that conclusion. This method outperforms simple supervised fine-tuning by 37.10%.
That is a massive jump.
Overall, GOLF achieves a 2.2 times improvement in sample efficiency compared to methods trained solely on scalar rewards. Furthermore, it maintains a higher policy entropy.
And in reinforcement learning, higher policy entropy means the model continuously explores diverse paths and broadens its solution coverage rather than collapsing into a narrow, repetitive pattern of behavior.
Yes. Replacing isolated numeric scores with aggregated group-level language feedback fundamentally accelerates how efficiently these models learn.
It moves them away from blind guessing and toward guided improvement, which raises an interesting thought for you to ponder.
Go ahead.
If aggregating diverse failure patterns helps an artificial intelligence learn 2.2 times faster, how much more efficiently could humans master complex subjects if we systematically analyzed our collective failed attempts?
Instead of only studying the successful ones?
Yes. Maybe we all need to spend a little less time looking for the clicker and a little more time analyzing why we missed the mark.